Hello, grade 7 students. This is day 16 of STP Mathematics 2A lesson series. Hope you have watched the day 15 video. We started the new chapter constructions and I guided you how to go through the construction steps and uh, how it is different from the drawing. Drawing, construction, two different things. And I clearly explained there. So how you can do the constructions, how to construct a line and how to construct a triangle and how to bisect the angle, how to bisect the lines. And we discussed many things, right? And by any chance, if you have not gone through that, please don't watch this video now. Instead, watch that video. Sometimes maybe 2 to 3 times you have to watch it, but be thorough with all the construction steps because that again you don't get a chance to have the live session like that. There, I explain everything. So what you can do, you can pause the video and you can do it like that. So then today I'm going to move to the other theory areas related to this topic, the construction. And I want to recall that recap things which you have done in grade 6. Now you just see the first theorem, we want to have an idea, the vertically opposite angles. How it works, children? That you have two lines and they cross each other, right? You have two lines and they cross each other. If you have the angles like this A, B, C, D, A and C are vertically opposite and B and D vertically opposite and they are equal. So that is a proven concept that you don't want to worry about it. When you come across with something like this where two lines cross each other and that it creates four angles like this. So then first you want to understand what are the vertically opposite angles. Then you should know that the vertically opposite angles are equal. A and C and B and D. Right, A and C and B and D. So here, according to this, P is equal to Q. No, that you can see that the Q and P, right? So they have just given you that the equal angles in the same letter, right? That we call vertically opposite angles. And children, that later I will explain that how we are going to write these reasons in an answer. Then the next one, angle at a point. So this is a point, and then all the angles around this point will add up to 360 degrees, right? If you have angles on the straight line like this, right, that you can see everything together add up to 180. That doesn't want to have the two angles, right? So then sometimes you come across with four angles like this, A, B, C, D. Still you get the same answer, A plus B plus C plus D. It gives you 180. The same answer you can find. So then here, the first theorem we learned vertically opposite angles are equal. The second theorem we revised that the angles at a point add up to 360. So then the next one, angles on a straight line add up to 180. You want to take your theory book and have a note with all these concepts, children, right? So angles and triangles. So this is kind of a revision that these things you have learned in grade 6, but you want to consider these as the revision session and copy down the note. And the next theorem, the sum of the three angles in a triangle is 180. You know that in a triangle, we do have three sides, no, children. And we do have three sides, we do have three internal angles too. So when you add any triangle, it can be a right angle triangle, it can be an obtuse angle or the acute, anything. If you come across with the triangle where you have three lines and three sides and three angles, so you add all these three angles together, it gives you 180. It may be a big triangle or a smaller triangle, it can be anything. It is add up to 180. I have shown how this become 180, right? 180 with a demonstration. So last video I showed you that how you are going to find my geometry videos. By any chance, if you feel that you can't remember that what you learn in grade 6, I have released a few videos. It's 5 years back that it's kind of that when I started my YouTube channel, I did them. So you can go to Geometry for Beginners. There is a playlist, Geometry for Beginners, and there I have nicely shown that how this become 180 using papers, kind of a demonstration, right? You can go and watch it. So then the next one, we are moving to the quadrilateral. Quadrilateral, we do have 4 sides and 4 angles. 4 sides and 4 angles. When you add everything together, it is 360. So I'll show you why it becomes 360 if I segregate this quadrilateral into 2 parts like this, right? I have 2 triangles. You can see one triangle is 180, the other triangle is 180. That altogether it gives me 360. So then I'll take another side. So then let's say I categorize this like this. Again, I have 2 triangles, 1 and 2. This triangle is 180 and this triangle is 180. Altogether, it is 360. Hope you can understand that any quadrilateral, it can be anything. Let's say that you have something like this. This is also a quadrilateral. No? So then if you see that I can divide it like this. So then 180, 180. Or else I can divide it like this. So 180, 180. Any quadrilateral, I can segregate into 2 triangles. One triangle interior angles will add up to 180. The other angle, triangle interior angles add up to 180. Altogether, it becomes 360. Therefore, sum of the 4 angles in any quadrilateral, it is 360 degrees. Right? So then we will move to the next theorem that you can see a triangle, but it is a different triangle. So you can see that they have marked something. So all the 3 sides are in same length. We call this kind of a triangle equilateral triangles. Equilateral triangles. Okay. So that all the 3 sides are equal in length and all the 3 angles are equal in size. So we know, let's say that if they are equal, let's say this is A and this is A and this is A, children, right? That what we learned little while ago. So then when you add all these 3 angles, that will add up to 180. Okay. A plus A plus A, what it is, children? It is 3A equal to 180. What do you mean by 3A? Now that you know how to solve this kind of simple algebraic equation, now you are in grade 7, right? So 3A means 3 times A equal to 180 degrees. So then the A is equal to 180 divided by 3. Then A is equal to 60. That is why they have marked them as 60, 60, 60. Hope it is clear. So the theory it says that when all the 3 sides are equal, all the 3 angles also should be equal. I mark all the 3 angles. If they are equal, I can mark them as A, no? And that little while ago we learned that in a triangle, all the 3 angles add up to 180. So with that knowledge, I can write A plus A plus A is equal to 180. So A plus A plus A is 3A. 3A means 3 times A. If I want to keep A only, I want to send that multiplication 3 to the other side. That becomes a division 3. So then it gives me the answer A is equal to 60. That is why they have marked it like this. So what's the learning outcome from this? So then if it is a triangle where all the 3 sides are equal, we name it as equilateral triangle. In an equilateral triangle, all the 3 sides are equal to each other and one angle will be 60 degrees, right? So then we will move to the next type, right? We will move to the next type, that is isosceles triangle. What do you mean by the isosceles triangle, children? You have 3 sides equal. You have 3 sides equal. Here they have shown So if that is equal, that we call the equilateral triangle and the isosceles triangle. And if that is so, these opposite angles will be equal to each other. Now I'm going to show you something. Let's say that I can't expect every time that the same two sides will be equal. In this case, that as you see that these two sides will be equal. Let's say that this another triangle that we have these two sides equal. Or another triangle we do have, let's say, these two sides equal. So based on that, you can see what are the two sides equal, right? So what are the two angles equal like this? Here, these two angles equal. Here, these two angles equal. Why is that? Now you can see here, so always it should be the opposite angle. So then we don't know which two sides will be equal. Based on that, you can decide which two angles will be equal, right? If I mark them in the same way, children, P, Q, R, right? R, and that here also P, Q, R, and this one is P, Q, R, like this. Now you can see that what are the two sides here? PQ is equal to PR. Now I'm going to show you something, right? And what are the equal angles? Q angle is equal to R angle. Look at this carefully. I'm going to show you something. And then the next one, PR side is equal to PQ. What are the equal angle? What are the PR? Not PQ, right? PR and RQ. Sorry, RP, right? Oh, I'm writing the same thing. PR and RQ. RQ. So what are the equal angles? P angle and Q angle. Then the next one you have PQ is equal to QR. What are the equal angle? P angle and R angle. Now you can see something, children, here. That you have P common, right? And then Q and R angle will be equal. You can see R and R common, P and Q angles will be equal. Here you can see Q and Q equal, P and R angles are equal, right? Any isosceles triangle, we know the two equal sides are there. No? So then the two angles at the base of the equal side should be equal. We can't expect always that we can see the PQ is equal to PR. It can be varied. So therefore, you want to understand that first you look at that if there is an isosceles triangle, first you identify what are the two sides equal. Based on that, you see the two angles at the base of the equal side. So then we know these are equal, right? These are equal, right? So that is how you want to understand the concept of isosceles triangle. Then I am moving to, so you can take time and try to understand, pause the video, so draw this nicely, and then you can understand that how it works. Then I'm going to moving to another topic, that is the parallel lines. If you have two parallel lines like this, children, right? Let's say you have two parallel lines like this, right? So these are two parallel lines. So then you know the distance between the two parallel lines are equal. And you have another line, we call that the transversal line, right? So we have discussed all these things when you were in grade 6, children. So this we call the transversal line. And that I'm going to mark all the angles like this, CD, right? E, F, G, H, right? Let's say that's something like this. What is the first angle type we are talking that when we have the parallel lines, children? Corresponding angles, interior angles, and the alternate angles. These are the three angle types we are talking when we have the parallel lines, right? So I'm just recapping everything, nothing new. You have learned all these things in grade 6, that we have the corresponding angles, F-letter angle, and the alternate angle, the Z-letter angle, then that you have the interior angles, right? So that we call the C-letter angle. So then we'll see how it works. So then if I'm talking about the corresponding angles, it can be like this, that we know the corresponding angles, you can identify it like this, children, right? So that is the F letter now. So in the F letter, it can be something like this, these two angles. Or that the F letter, you can see here to this side, something like this. Or sometimes you see it like this, right here, right? And then sometimes you can see it like this. Anyhow, you can see that we are talking about the same type of angles, right? So then these are equal. Now, based on this, now you just go through this. You'll see what is the first one I can mark. That you just look at the shape and write down. So then what is the first pair I can write? D is equal to H. And what is the other pair I can get? C is equal to G. You imagine that when I'm telling the letters, that you just imagine the flat letter over there. D and H, C and G, and then E and A. Then the third one, F and B. F and B, and E equal to A. Something like this. D, H, C, G, E, A, F, B. So those are the corresponding angles. So I'm double checking. D, H, C, G, E, A, F, B. Yes, it is correct. Then I'm moving to the next type, the alternate angles, right? Alternate angles, so that is Z letter. So then it can be like this, it can be something like this, and sometimes that it can be the other way around, something like this. In that case, this. So now you just move to the letters that you just see, C and F. C and F is equal. Then we can say D and E. D and E. What you can do, children, first you D and E. CF, yeah. So first you draw this nicely, then you mark the letters. So then the next type, I'm going to take the interior angles, right? So I'm going to take the interior angles. It's like this. Interior angles, they are not equal, add up to 180. They are add up to 180 degrees. So how we are going to have the interior angles? Something like this. Or that you have the line something like this. In this example, children, that you have CEDF. So then you can write C plus E equal to 180 degrees, T plus F equal to 180 degrees, right? So that is all about the parallel lines, right? So then you want to recall here that they have mentioned the corresponding, the alternate, and the interior angles are supplementary. You should know that when they use the word supplementary, it is at up to 180 degrees, right? Okay, so what you want to do, children, now you have the theory with you that we recap everything. So you can do all these exercise 3A, right? So then you can do that these are construction steps where we can practice them with the past papers. Yeah, so then the next day we want to move to the solids. So these the nets, how we are going to get the nets, I will explain them. So this is very interesting one. So you want to keep that the light cardboard, not the harder one, right? If you can keep the light cardboard with you, so then you can practice these things, children, right? So then it's very interesting once you can share the images, that once you are done with these things, so then I can share them on my Facebook page also, that you can do these and show the images that you just be with the solids you created, and you just send me a snapshot. So then that will be very interesting. I can share with everyone. So then that will be a reward for your efforts. So then the next day we are working on these solids. What you want to do, that you want to have your uh, light cardboard, something that you can do it. The A4 papers I don't recommend, because it's sometimes it's difficult for you to manage, and you can have the light cardboard, that not the harder one, and then you can have your scissor, then the glue, eraser, pencil, ruler, all these things. So then we will make these solids the next day. Okay, children, so we'll meet again next day. Till then, stay safe. Bye.